Okay, good morning everyone. Once again, welcome back to Jagadish College of Science. This video is from Mathematics Department, and I am your Mathematics lecturer, Jagadish. Okay, uh, you guys already know that is we started your PSC 5.2 Laplace transformation classes, and in last class we discussed about your some properties of Laplace transformation. Okay, in that we studied change of scale and first shifting property and multiplication property. Also we studied and we also solved some problems related to that properties. Okay, so today I'm going to start your fourth property, that is division property. It is division by t. Okay. Okay, so your property number 4 is division by t. Okay, that means the statement is if Laplace transformation of f of t. Okay, if Laplace transformation of f of t is equals to f of s, okay, then the Laplace transformation of a function, divided by t, okay, is equals to integration over s to infinity f of s, okay, into ds, or we can write it is integration over f of s. So integration over s tends to s to infinity, and this function we will write as our f of Laplace transformation of f of t into ds with respect to s. Okay, so this is your statement. If Laplace transformation of f of t is equals to f of s, this is your definition, then the Laplace transformation of a function divided by t is equals to integration over s to infinity f of s ds. Okay, we have to prove these functions. So using these functions, we will prove. Okay, first we have, that is our Laplace transformation definition is Laplace transformation of f of t is equals to f of s is equals to, this is our definition, that is integration over 0 to infinity e to the power minus st f of t dt. Okay, this is our definition. Using this function we will prove this one. Okay, that is f of s is equals to integration over 0 to infinity e to the power st f of t dt. Okay, this is our definition. Now we integrate this function with respect to s between the limits s to infinity, because we want the limits s to infinity. Okay, that's why we will take the limits s to infinity. Okay, now we get here. Now we get here this function integration over 0 to infinity f of s into ds, and in RHS side that will becomes integration over s to infinity, and this is our normal remaining function, that is integration over 0 to infinity e to the power minus st f of t dt into ds. Okay, this is integration with respect to s between the limits s and infinity. Okay, here. Now the next step is, now you guys know, by the changing of order of integration, we will change the integration positions. That means here integration over 0 to infinity into integration over s to infinity e to the power minus st into ds. Now into our remaining our f of t into dt function. Okay, by changing the order of an integration. Okay, so this function we will write here, it is integration over 0 to infinity as it is, and this function when we integrate with respect to s. Okay, now integrate with respect to s, we will get our e to the power minus st divided by minus t. Okay, and the limits is s to infinity is there. Okay, and our remaining function, that is f of t into dt, we will write as it is. Okay, here, so integration over 0 to infinity is our outside function, and integration over e to the power minus st minus 3 we will get, with respect to s. So this function also will write here integration over 0 to infinity e to the power minus st divided by t, and the limits is s to infinity, and our remaining f of t dt as it is. Okay, here. Okay, now when we apply the limits, that lower limit to upper limit to minus lower limit, we will get e to the power minus st by t is equals to upper limit is infinity, lower limit is s. Okay, so e to the power minus s into infinity. So infinity into t is get infinity only, and in here minus e to the power minus s function, lower limit is s only, so s into t divided by t function as it is. Okay, so this is our lower limit minus upper limit minus lower limit function into our remaining function as it is, that is f of t into dt. Okay, so here integration over 0 to infinity, and this function e to the power minus infinity minus e to the power minus st divided by t into our f of t dt function as it is. Okay, so this function here, this function will get 0 minus e to the power minus st divided by minus t, okay, into f of t dt as it is. So here integration over 0 to infinity. This is our according to Laplace transformation definition. Okay. Now, so now this function we will get 0 to infinity e to the power minus st divided by minus t f of t into dt. Okay. Yes, 0 e to the power minus st becomes 0. That's why we are neglecting it. And remaining function we will write here. That is integration over 0 to infinity minus e to the power minus st divided by minus t into f of t into dt. Okay. So this function we also write as 0 to infinity. So minus minus will get cancelled. E to the power minus st f of t into dt whole divided by t. Okay. So again this function we will write as integration over 0 to infinity e to the power minus st f of t divided by t into dt. Okay. So this function you write it is okay like this. So you guys already know our integration definition, the Laplace transformation definition, that is e to the power minus st f of t dt. Okay, here we get integration over 0 to infinity e to the power minus st f of t by t into dt. Okay, so this function we will write as integration over 0 to infinity. Sorry, this function we will write as okay, this function we write as Laplace transformation of f of t by t into dt. Okay. So here our final answer is we get that is towards uh, integration over f of s. Okay. This function we will take in the starting only. Integration over s to infinity f of s is f of s ds is equals to, this is our answer, that is integration over 0 to infinity e to the power minus st f of t by t into dt. Okay, so this function we also write as Laplace transformation of f of t by t. Okay, so hence that is this our answer. Laplace transformation of f of t by t is equals to integration over s to infinity f of s into ds. Okay, or we write here that is Laplace transformation of f of t by t is equals to integration over s to infinity, that is our remaining Laplace transformation of f of t. Okay, wait. Okay, here that is Laplace transformation of f of t by t is equals to our integration over s to infinity f of s ds, or we write it as Laplace transformation of f of t by t is equals to integration over s to infinity and our Laplace transformation of f of t into ds, okay, with respect to s. So wherever we get the function, our Laplace transformation function divided by t, on this time we use this property, that is Laplace transformation of our given function divided by t. Okay, any given function divided by t, that time we will write this function, that is integration over s to infinity Laplace transformation of f of t. Okay, with respect to ds. Okay, one example is here. It is uh, find the Laplace transformation of sin t divided by t. Okay, sin t divided by t. Our solution, first we will write the given equation, that is sin t by t, and we know that this is our property number 4, that is division by t. Okay, that is Laplace transformation of f of t divided by t is equals to integration over s to infinity f of s into ds, or integration over s to infinity Laplace transformation of f of t into ds. Okay, so class sir. Bye. Okay, sorry for the disturbance, guys. Okay, this is our given function. That we know that this function, that is our property number 4, and this is our equation. So let me write it is Laplace transformation of sin t divided by t is equals to sin t divided by t is equals to integration over s to infinity our Laplace transformation of sin t into ds. Okay. Okay, and here guys, you know that is our Laplace transformation of sin t. Sin at formula is a divided by s square plus a square. So here a value is sin t, that is 1. So 1 divided by s square plus 1 square becomes here, that is integration over s to infinity 1 divided by s square plus 1 into ds. Okay, and this is integration formula, that is 1 divided by x square plus a square is equals to tan inverse of x. That means tan inverse of s, here this function is. So that's why we will write it is as 1 divided by s square plus 1 is equals to tan inverse of s with respect to our limits is s to infinity. Okay. So here your next step is when we apply the upper limit minus lower limit, it is tan inverse of s. Upper limit is infinity, lower limit is s. That is tan inverse of infinity minus tan inverse of s. Okay. So this function will get your tan infinity. Tan inverse of infinity is pi by 2 minus tan inverse of s is as it is. Okay. So you guys know already the pi by 2 minus tan theta is equals to cot inverse of theta. Okay. So here we will get as pi by 2 minus tan inverse of s is equals to cot inverse of s. Okay. So your final resultant answer is, that is Laplace transformation of sin t divided by t is equals to cot inverse of s. Okay. Okay, we will go for next problem, that is find the Laplace transformation of sin h t divided by t. Okay, sin hyperbolic function t divided by t. Solution, first we will write the given equation, that is sin h t by t, and you guys know that is our Laplace transformation property number 4, division by t, that is Laplace transformation of f of t by t is equals to integration over s to infinity and remaining our Laplace transformation of given function into ds with respect to s. Okay, and here we have that is Laplace transformation of sin ht divided by t is equals to integration over s to infinity and remaining our Laplace transformation of sin ht into ds. Okay, you guys know already Laplace transformation of hyperbolic of at is equals to a divided by s square minus a square. Okay, careful here, s square minus a square here, and here a value is 1, that is 1 divided by s square minus 1 square. Okay, s square minus 1 square. Okay, here this is your answer is that is integration over s to infinity 1 divided by s square minus 1 into ds, where sine of Laplace transformation of sin h of at. Okay, sin h of at is equals to a divided by s square minus a square. Okay, and one more formula is there in your integration. For integration means I hope it is on for 12th class. That is 1 divided by x square minus a square integration over 1 divided by x square minus a square dx is equals to 1 divided by 2a into log x plus a divided by x minus a plus c. Okay, this is your integration formula I have to write here. So using this formula we solve this function, that is integration over s to infinity 1 divided by s square minus 1, here x value is s, a value is 1 into ds with respect to s, it is 1 divided by 2 into 1 divided by 2a into log of x plus a is s plus 1 divided by x minus a is s minus 1, where the limits is infinity, s to infinity. Okay, first we simplify this function because we want to neglect infinity terms, that's why we will take simplify this function, that is 1 by 2 1 by 2, 2 into 1 is 2, 1 by 2 log of this function we will write as s plus 1 divided by s minus 1. Okay, we will write this function, it is log of 1 plus 1 by s divided by 1 minus 1 by s. Okay, when we cross multiply by this, you will get same answer only. So here your next step is 1 by 2 into log 1 plus 1 by s divided by 1 minus 1 by s, where your limit is 0 s to infinity. Okay, when we apply the upper limit minus lower limit, okay, here this is your upper limit, that is 1 by 2 into log 1 plus 1 by s divided by 1 minus 1 by s, where limit is s to infinity. Now we apply the upper limit minus lower limit. This 1 by 2 is constant term, we keep outside, and log of 1 plus 1 by infinity, log of 1 plus 1 by infinity divided by 1 minus 1 by infinity. Okay, minus, so lower limit, that is log of 1 plus 1 by s divided by 1 minus 1 by s. Okay, so here we'll get, that is log of 1 plus 1 by infinity 0 divided by 1 minus 0. Okay, so minus log of this remains same, that is 1 plus 1 by s 1 minus 1 by s, and this function we will get log of 1 minus log of this function we will write s plus 1 divided by s minus 1. Okay, so log of 1 value is 0 minus the remaining log of s plus 1 divided by s minus 1 as it is. Okay, this function we will write here only. Here that is log of 1 minus log of s plus 1 divided by s minus 1, s minus 1 minus log of s plus 1, that function we will take as 1 plus 1 by s divided by 1 minus 1 by s. Okay, so this function we will get, that is log of s plus 1 by s divided by s minus 1 by s. So here s will get cancelled, so answer will get same only. That is log of s plus 1 divided by s minus 1. Okay, this is your function. And log of 1 value is 0. So remaining log of s plus 1 divided by s minus 1 as it is. So 1 by 2 constant term, here my negative term is there. We want to take this positive term, then we'll interchange the values. That is log of s minus 1 divided by s plus 1. Here the log of x is equals to minus log of 1 by x. Okay. So our final resultant answer is, that is Laplace transformation of sin ht by t is equals to 1 by 2 into log s minus 1 divided by s plus 1. Okay. So your Laplace transformation of f of t by t formula is, that is integration over s to infinity, then Laplace transformation of f of t into ds. Okay, that means if this function will come, on that time we integrate the s function with respect to, sorry, limits s to infinity with respect to s, our given function. Okay, I hope you guys understand these all problems. Okay, I will repeating once again. That is, if you have any doubt, then ask me via through WhatsApp. Don't worry. Okay. Thank you. Thank you for your all.